Alright, for this first problem, it's asking for when x is less than or equal to 4. Let me adjust something. Okay. So we have to first draw out the function, which is this. Let me just draw my points here. Alright, and since it's asking for it has to be less than or equal to 4. Since all this is less than or equal to 4, because this is 3 right here, I'm just going to completely keep this like this. And since 4, the y value for 4 would be out of this graph, I'm just going to keep it like this. Then 4 is, or actually, you know what, I'll just do something like that. And then x plus 3, and then 4 is less than or equal to x, which is less than 7. So basically, this means it has to be an open circle, and this would be a closed circle. So x plus 3, let's just create that graph right now. Alright, that's not... Let's see. Okay, I think that's about right. And then it says 4 is less than or equal to x, which is less than 7. So we have to do 1, 2, 3, 4. So it would have to be from right here. So let's just erase everything else that's before this. Not that. Just erase all of this. And then you just have this going until 7. So this is 4, 5, 6, 7 right here. And then here, this is where we would stop it. Let me just adjust this line a bit. And then here, there would be an open circle. And then for this last one, absolute value of 2x minus 4 is x is equal to greater than or equal to 7. So once again, let's draw out the function. Let's see. So it's x is greater than or equal to 7. So that means you would have to start this with a closed circle at. You'd have to start with a closed circle starting at the value for x value for 7. So whenever x is equal to 7, y is equal to 10. So might as well just start like right here. And then you can just start like that, and then it can just go like that. Because it's 2x, so it has to go at a rate of 2. So it could be like that. Alright, and I believe, let's just put an arrow there, and I believe that is it for that. The domain for this one, since the domain for quadratics is all real numbers, so at least on this side it's going to be a negative infinity. And since absolute value functions, the domain is also always all real numbers, the range will also be infinity. The domain on the right side will be negative infinity, infinity. For range, as you can see, the lowest point of the graph is going to be right here, which is 2. So we can, and it's an absolute value, it's not absolute value, sorry. The exact value is 2, so we can keep it like that. Then it appears that both on the left side and the right side, it goes to infinity. So it can be infinity here. So the range is 2 to infinity. Then we have to transform the piecewise function. So this one, alright. So we have to take this function, we have to move it to the right 4, then reflect it over the x-axis, and then move down 2. Right, let me just paste this all over. Alright, so we have to move this to the right 4, so let's just take this entire thing and move it over to the right. 1, 2, 3, 4. So it would look like that. You have to reflect it over the x-axis, so we just have to do a perfect reflection like this. Whoops, no, like, let's do it like this, and then this is a difference of 3, this is a difference of 6. And then so on and so forth. Okay. So we can just have this part of the, we can have this part of the function just be like this. And then over here, this has to be reflected like this. So this is a difference of 7 right here. So we'd have to move this 1, 2, 3, 4, 5, 6, 7. Like this. And then it would have to go down instead of up. And then it would have to go at negative 2x instead of 2x. And then since this entire thing has to be moved down 2 as well, let's move this down. 1, 2. Like, so that would be the transformed function. Now to find the inverse of f of x. This is, for this one we just simply have to replace the x's with y's and the y's, whoops, wrong thing. We have to replace the x's with y's and the y's with x's. And then just solve it from there. Whoops, Apple Pencil died. Let me just charge it for a bit. Alright, it should work now. So, okay, it's still not working. Let me give it a few more seconds. Alright. Now let me see. Okay, it's working now. So basically you just have to replace the x's with y's and the y's with x's. So we have to do it like this. And then basically we just have to solve for y. So now we're just going to do x minus 2 is equal to y minus 1 cubed over 4. Then now we have to multiply it out. So let's do 4 times x minus 2 is equal to y minus 1 cubed. Now we have to take the cube root of both sides. So this will end up being cube root of 4 times x minus 2 is equal to y minus 1. And then, whoops, and then lastly we'll just move the 1 to the other side. So this would be plus 1 is equal to y. So that means this will be the final function, the final inverse. And then, so state the domain of the original. So the domain would be all the x values. And it appears that all the x values would work, every single x value, every single real number would work as an x value here, because there's nothing on the denominator that makes it end up as it being divided by 0. So I'm going to put the domain as all real numbers. And any restrictions to the original domain that we have to make here, there are not any restrictions that I believe of. Yeah, I don't believe there are any restrictions. And then the inverse function, it's right here. Let me just write it out again. So it would be the cube root of 4 times x minus 2 plus 1 is equal to y. Or I'll replace the y with f of x. That's probably better. the domain and range of the inverse. Once again, since cube roots allow for any number to be in the range and the domain. It's not like square roots or fourth roots. Because if you take the cube root of a negative number, you can get a negative number. So the domain and range will be both are real numbers. Alright, so now in order to verify if these are inverses, we have to use composition. So what I'm going to do, I'm going to plug the original function into the inverse function. So let's write out the inverse function. So it's the cube root of 4 times... Well, now instead of writing x, we have to plug in the actual original function. So we can write x minus 1 cubed over 4 plus 2. And then, and then let's remove this, and then minus 2, like that. And then plus 1. So basically what we have to do, we have to simplify this entire thing out, and if we end up getting x as the final answer, they are inverses. So let me fix this so it looks more like a cube root symbol. Alright. So first what we have to do, we have to, this plus 2 and minus 2, they cancel out. So let's just rewrite this entire thing without that. So we would have x minus 1 cubed over 4, and then just plus 1. And now, as if you realize, you can multiply out this 4 on the top. So you can do 4 times, sorry, not multiply out, just multiply. And you can just multiply 4 times x minus 1 cubed over 4. And then these two 4s cancel out. So then you would just end up getting the cube root of x minus 1 cubed plus 1. And then the cube root of something cubed is just going to be that something. So you would just end up getting x minus 1 plus 1, which is just x, because the 1's cancel out. So yes, these indeed are inverses. Alright, and that's it.